Okay, so right now, as we continue with the nature of roots, I'm going to explain the 4 different types of roots that we get, right? The first one, here, this sign, it means a discriminant or delta. What is a discriminant? From your quadratic formula, you take this part, which is b squared minus 4ac. This is what we call the discriminant, right? Now, this triangle is representing the b squared minus 4ac. So now we're told that our delta or discriminant is less than 0, meaning to say that the numbers that you're going to get under the hood of a square root, it will be a negative number. It means those numbers are what we call non-real numbers. Non-real numbers simply implies that that number cannot be found on the number system or on the number line, right? Then we've got scenario number 2, where our discriminant is more than or equal to 0. More than or equal to 0, and very, very important, that number is a perfect square. So we'll be saying square root of a perfect square. Example, 49. Square root of 49 is what? 7. It's a perfect square. When you find your discriminant to be a square root of a perfect square, the type of roots which you're going to get, number 1, it's going to be part of your number line, which is a real number. Number 2, it's going to be a what? A rational number. And last but not least, the roots are not going to be equal. So you may find that x is equals to 3 and x is equals to negative 1. They can have different x roots. That's what we mean when we say unequal. If you find a perfect square, you must know the roots are unequal. But remember, square root of 49 is what? Is 7, which is what makes it to be a rational number. Remember, under the group of rational numbers, what do we have? We are having our whole numbers, we've got our natural numbers, we've got our fractions, we've got our ratios, we've got our terminating decimals, and so forth and so forth. That's what rational means. It's being taken from the number system. And real number, it just means that the combination of rational numbers and irrational numbers. Then we go to scenario number 3. Scenario number 3 tells us that the discriminant is more than or equal to 0. But the number that you're getting is not a perfect square. Very, very important. The number is not a perfect square. For example, you've been given square root of 5. Now, we know from the work that you have previously done that the square root of 5, it's an irrational number. It gives you what? Non-terminating decimals. Long numbers, those decimals, they never come to an end and there is no pattern, right? So when you get such, it's a real number, irrational in the sense of non-terminating decimal, unequal roots. The roots are not going to be equal. Maybe I've got x is equals to 5 and x is equals to 2. But not like this. 5 comma maybe 2 1 something. Remember we said irrational, so it can't be a natural number. 2 comma 2 something. Just an example, right? Then we've got situation number 4, where your discriminant is equal to 0, your delta is equals to 0, meaning to say that when you use your b squared minus 4ac, you are going to get a 0, right? When you get such, it tells you to say that your roots are going to be real numbers, rational numbers, and their roots are going to be equal roots, right? So it's one thing to talk about theory. Let's look at a particular equation. So here we've been given an equation which says x squared minus 6x plus 9 is equal to 0. My a is found in this place, which is 1. My b is the coefficient of x, so I take this sign as well. This is where my b is located, and this is my constant, the c. So b, I start with b, which is now negative 6 squared minus 4, open bracket, my a is 1, multiplied by the c, which is 9. Then we say it is equal to 0. Negative 6 squared, which is inside the brackets, gives us what? Positive 36. And negative times positive, it's a negative, times this positive, it's a negative. So we've got a negative sign. 4 by 1 is 4, and 4 by 9 is what? 36. And when I say 36 minus 36, what do I get? It is equal to 0. Now, if I come to these 4 conditions, I've been told where my discriminant is equals to 0, this is the last condition. It means that my root is what? Real, rational, and equal roots, right? You can take this and place this entire equation and use a quadratic formula. You will find that the roots, the x, it will give you identical solutions, right? Okay. Then we go to another equation. Let me look for another equation. So this equation that we have here says, it states that you've got x squared minus 5x minus 6. Let me just erase here. So we've been provided with x squared minus 5x plus 6. Oh, it's minus 6, sorry for that, which is equals to 0. Where is my b? Negative 5 is the b. A is equals to 1, and c is equals to negative 6. B squared, which means negative 5 squared, minus 4 multiplied by a, which is 1, multiplied by c, which is a negative 6, we say is equals to 0. When I say negative 5 squared, I get 25. When I say this negative sign multiplied by that negative sign, I get a positive. When I say 6 multiplied by 4, I get 24. Multiplied by 1 is still 24. And when I say 25 plus 24, I get 49. So this is equals to 49. Now, 49 is what? Is a perfect square. Remember, under my example here, it's a perfect square. Now, since it's a perfect square, the 49, it tells us that it's a real, rational, and unequal roots. That's the type of root this is. Real, rational, and unequal roots. Then just like that, we found our solution, right? Thank you. Join me. So what we have done so far, we've dealt with this type of nature of roots. We've dealt with that already. There's another video which I dealt with the non-real. So we're just left with this last. Join me on the next video where I talk about this scenario. Thank you.